Yes, I have a case study. So we have a bunch of kids playing around fire in the mountain. So basically, the rule is that whenever a teacher calls out a number, so say she calls out 2, then students are supposed to arrange themselves in groups of that number. If she calls out 10, then the children have to make a group of 10 students. So whoever is not part of any group of that particular size, they are out. For example, here the teacher, I think she has called out 1, 2, 3, 4, 5, 5. So we have around 6 groups, and you have 3 kids who are not part of any group and they are out basically. Now the question is, what's the best and fastest way to find the total number of students in the scenario given? So we have this scenario. I want to find quickly how many kids are there. How should I do it? What is the fastest way of doing it? I want to count them basically. Yes, what we can do is we can look at, there are 5 students and in a group, that is, and we have six groups, right? And we have at the end 3 students left. There are 5 students and there are 6 groups and we have 3 students who are left. Or I can think of this as, there are 6 groups, each with 5 students, and 3 are left. Can I think it this way as well? So mathematically, how do you go on representing this is the question now. So I can think of this as group of 6, each made up of 5 students, and remaining we have 3 students. Now, to find the final answer, do you think it is best to go on adding 5 plus 3, that is 8, and then we have 48? Is that the answer? How many students are there? Let's count it. There are 5. 5 plus 5, 10, 15, 20, 25, 30, 33 students are there. Here there are actually 33 students. But here we got 48 students. Why is that? What did I do? I got 8. How did I get 8? I added 5 and 3 and I got 8. So that is the mistake. So basically 6 into 5 plus 3 we can't go in this way wherein you add 5 and 3 and then multiply with 6. That is not the way. The actual way is 6 into 5, that is 30, plus 3, that is 33 students is the right way to go on doing this. That is, we have to do division and multiplication before addition, even subtraction. Basically, again, we are looking at multiplication before addition or subtraction is what we are trying to learn over here. Okay. Okay. Let's understand the expression with the help of addition. So let's look into 6 into 5 plus 3 in terms of addition. First, let's recall one fact. What is that? That multiplication is repeated addition. Do you guys agree? Multiplication is repeated addition. Therefore, 6 into 5 is what? 6 being added 5 times. That's one of the ways of thinking about it. Do you guys agree? So basically, 6 into 5 plus 3, I can rewrite this as 6 plus 6 plus 6 plus 6 plus 6 and then plus 3. And so we have 6 plus 6 plus 6 plus 12, 18, 24 and 30. And then 3. And so this is 33. So here too, what is that we did? We did 6 into 5 first. Can you see that? We did 6 into 5 plus a 5 first and then added to 3. And then added the 3. Added the 3. And that's what the entire idea is about. Okay, the entire idea is that if we have a multiplication, do that first before you do addition. As simple as that. Okay, let's kind of concrete the idea with a similar scenario as this. For each of the case below, that is, here, write the expression and identify its terms. Okay, let's do this. It's a recap of quite a few things. If the teacher had called out 4, so okay, Ruby would have written. So basically, what is the expression written if the teacher would have called out 4? Say these kids are eliminated, we'll not bother with them. We have 30 students. So 30 students naturally would have grouped into how many? So 4, 6, 4 are 27, 4 are 28. 28 plus 2, right? This will give me 30. You guys agree? So how do do the math? 28 plus 2 will give me 30. Is it not, guys? So basically, this will get removed. They lost. These people moved on to the next round. And this was the initial number. Do you guys agree? So let's take this 28 students and see what will happen if the teacher had called out 7 students. Ruby is the person who is writing the number on the board, I guess. So what will happen over here? The teacher calling out 7 leads to 7 4s are 28 plus 0. So there is no one eliminated. What if the teacher called out, say, 6? So we have 6. Okay. Then the group 6. So 6 4s are 24 plus 4, right? This will give me 28. So here too, I'm doing multiplication before addition, right? So there are 6 in a group and there are 4 groups. And we have 24 as a total number of students. So that's your teacher. She called out 6. And this is your resulting, right? This is your resulting scenario. So there are 4 groups. This kids happen to lose. And that's the number of students in each group. Each group has that's that, right? Okay. Here are 2 pictures. So we have picture A and picture, say, B. Which of these 2 arrangement matches with the expression 2 into 5 plus 3? Okay. This is again a good way to think about this particular concept. My question to you guys is, do A and B, figure A and B, do they represent this particular scenario or only A or only B represent it? Your first clue is it's actually A if not B, not both. Answer is A. Can you guys figure it out? Why is it so? We can clearly see that there are 1 2 1 2 1 2 1 2 1 2. So there are 2 blocks and 5 such groups. Or I can put it as there are 5 groups of 2 and then 3. There are 5 groups of 2 and then 3. This is the right way of representation. This is your 5 groups of 2. So there are 5 groups and each group has and then 3. Same as whatever we did with the kids. See, it's the same math. It's not complicated. This actually is, I mean, if I ignore the color, there is 1, 2, 3, 4, 5, 6, 7, 8. There are 2 groups, right? First thing is there are 2 groups. I should have told that first. And there are 8 in each group. So there are 2 groups and each has 8 blocks. Okay, so that's that. So what did we learn? Let's have a look at all of this again. If we happen to get an expression, right? Arithmetic expression wherein you have bunch of numbers being added and multiplied or even divided. We have not taken the case of division. We'll take it as a separate example. We have to do the multiplication before we do the addition. Okay, we have to do the multiplication before addition. So if we happen to do addition before multiplication, it gives us a weird number. So we happen to see quite a few cases. So clearly this group had 33 students. So I can think of this group as, made up of 6 groups, each containing 5 students, and 3 were left out. Right? So that's what we understood from that. And the same idea continues over here. So I can read this as 4 groups containing 7 students, or I can tell that there are 7 groups containing 4 students and 2 were left out. Again, here we had 4 groups containing 6 students each and 4 were left out. And this adds to 28. This number 28 only makes sense if you do the multiplication before addition. Right, guys? And we saw why this works. This goes back to the fundamental, that the very fundamental of multiplication being repeated addition. So if I take up that funda, so 6 into 5 will be 6 plus 6 plus 6 plus 6 plus 6, so on and so forth. And so 6 into 5 plus 3 will become 30 plus 3, that is 33. And so we have, this as the concept.